Hello everyone. In today's video, we are going to see the implementation of the Horspool string matching algorithm. And those who are watching this particular video, I would recommend or I would suggest you to see my previous video wherein I have discussed the theoretical concept of Horspool string matching algorithm as well as the tracing of Horspool with a few examples and the algorithm as well as the time complexity of Horspool string matching algorithm. Note that in case of Horspool string matching algorithm, before we search the pattern in the given text, the first thing that we are supposed to do is we need to construct a shift table. We need to construct a shift table based on the characters of the pattern. So let's start the implementation. First, I'll include the header files. I will be including string.h because we need to extract the length of pattern as well as the length of the text. I will write a macro for the size of the shift table. I will take all the ASCII characters into consideration. I am taking the size as 256. If I just take only the printable character, you can have the size as 2 power 7. Okay, something as 128. Now let me have the shift table denoted with array table. I am taking the shift table name by name table. I have taken it as a global variable because it needs to be used in both the function, that is in the function of the construction of the shift table as well as in the function of Horspool wherein I am searching the pattern. Now let's start with the construction of shift table. Void shift table. You know that the input to this shift table is the pattern. Let us denote the pattern with capital P, and I'll assume that my pattern size is max is 25. Anyway, we know that the length of the text is more when compared to pattern. I've just taken the size of my pattern as 25. You can just take it as 5 or 10. It shouldn't harm your program. I'll take two variables, one by name I and m, where m is nothing but the size of my pattern, string length of p. Now, what we initially do in case of the shift table, we are going to assign the length of the pattern to all the location of the shift table table. So, I'll run a for loop for I is equal to 0, I less than size I plus plus table of I is equal to m, where m is nothing but the string length of pattern, that is the size of the pattern. That is, you might have observed that at most I can shift the pattern by the number of characters in the pattern, that is the size of my pattern. Next, for the characters in the pattern, I should update the shift value. For I is equal to 0, I less than or equal to m minus 2, I plus plus. Please note that once again, here I should not consider the last character. For I is equal to 0, I less than or equal to m minus 2, I plus plus. Table of p of I is equal to m minus I minus 1. Now, this is the function for constructing the shift table. Now let's go for the function of the Horspool. If you have observed the algorithm that we have discussed in the previous video, the algorithm was returning either -1 or it was returning the position where the pattern is there in the text. So what we will do, we'll have the function name as Horspool, and the return type of this function as integer. Now to this function name, our input are the text and the pattern. Let the text be denoted with T of some size 100 and The second input was a pattern which was denoted with the P of some size at 25. Of some size 25. Now the variables, let me have m, n initially, where m is nothing but the size of the pattern, string length of P, n is equal to string length of T. That is my text. Let's have K and then I. If required, we'll use some other variables. First, you might have seen what is the first step that we are supposed to do. We used to align the first m characters of the pattern with the first m characters of the text. Now I need to know the position of the pattern to be compared in the text. So I'll have my I value as m minus 1. I value as m minus 1. Now we know that the maximum number of iterations are while I less than or equal to n minus 1. So in each iteration, what we are supposed to do, we need to compare the characters of the pattern with the characters in the text. If there are the number of matches are k, then it implies that I found my pattern in the text. So to have the number of matching, if you do remember, we have taken a variable k in the algorithm. I'll use the same k variable k, which is initialized to 0 first. Next, I'll take a while loop while k less than m. This was the first condition, and p of m minus 1 minus k is equal to p of I minus k. This was the second condition. If this condition were true, I used to update my k. K is equal to k plus 1. Now after updation, somewhere at any point, if my k is equal to m, I need to return the position of the pattern in the text. Return I minus m plus 1. Else, what I need to do, I need to update the value of I. I is equal to I plus table of T of I. Now close this while loop. Now after iterating n minus 1 times, wherein initially I had my I value as m minus 1, after coming out of the while loop, if you are not able to search the pattern, if the pattern is not there in the text, we are supposed to return minus 1. So return minus 1. Close the function. So this was about the Horspool string matching function. I repeat, m is the length of the pattern, n is the length of the text. Initially I have initialized I is equal to m minus 1. That means I, if this is my text, if this was my text and this was my pattern, so these are the m characters of the pattern. I need to compare the last character of the pattern with the last character of the text. Now the text is being indexed from 0 to n minus 1 and pattern 0 to m minus 1. So this m minus 1 character of the text should be compared initially. Hence I is equal to m minus 1. And the maximum number of iteration, if I assume that the pattern in the worst case it has been shifted only one time, so it can go up to n minus 1 times. Hence for I is equal to I less than n minus 1. So I am taking this k. Why k? Number of characters compared. In any iteration, if I have how many characters that I have compared. In any iteration, if k is equal to m, then it implies that I have found my pattern in the text. If not, then I should shift the size of, I should shift the pattern depending upon the shift value of this particular character. I is equal to I plus the table of T of I. Now after going through all the characters in my text, if the pattern is not there, then I am going to return minus 1. So this was about the Horspool function. Please note that this Horspool function has two arguments. The first argument is the text and the second argument is the pattern. Now coming to the main function. Coming to the main function, let's write the main function. Now in the main function, we will have a variable for text of size 100, a variable for pattern by name pattern of size 25. Sorry, this is a character array. And to hold the return value of Horspool function, I'll use a variable by name result. Now first read the text. Now you can use either getS, because here if you just use a scanf with just %s, it will just read one word. So what you can do, either you can use getS or you can use scanf also. But while using scanf, make sure that until a new line character you are reading percentages until a new line. So text. Now what is the second thing? Read pattern. Printf read pattern. Now assuming that my pattern is just a single word, I'll use %s. Even if your patterns are two words, you can use the same thing. Now, after reading the text and the pattern, what is the first thing that we are supposed to do? First thing is construct the shift table for the, shift table for the pattern is being constructed in the Horspool algorithm. Now you can directly call the Horspool algorithm and store the result in the variable result. Result is equal to Horspool of text comma pattern. If result is equal to -1, printf pattern not found. Else printf pattern found. If you want to print the position, you can print the value of this RAS, pattern found at position %d, which is nothing but result. Return 0. Close this. So this should be fine. This was about the implementation of Horspool string matching algorithm. Thank you.